So welcome to video, I don't know, what are we at? 1, 2, 3, 4, 5, maybe 5, video number 5 or 6. Today we're going to talk about the law of cosines. Last video, we talked about the law of sines, and we said that the law of sines is a way to use trigonometry with non-right triangles. Law of cosines is the same thing. It's just a way of applying trig to non-right triangles. So I think, whenever we do this, I think it's really important to know why it works, because applying trig to a non-right triangle seems like it goes against everything we've talked about. We said trig is, based on the proportion of sides in a right triangle. Now we're saying it applies to non-right triangles? That seems weird. So we're going to try and, I'm going to try and explain why law of cosines works and why it makes sense. This proof is a little bit messier than the law of sines one. Law of sines is pretty easy to do. Law of cosines just requires more algebra. So what I'm going to do is I actually have the proof already done on the slides. I'll walk through it step by step, and then for you at home, you can be looking through the slides and kind of make your own. Listen to my explanation, see the steps on the board, and then try and figure it out on your own. Okay, or try and figure out what I'm saying. Anyways, let's get into it. So we're going to explain why the law of cosines works. Again, then we're just going to use practice problems. And once we get these two ideas down, law of sines last time, law of cosines now, we can be ready for our 10-point project, which is perfect for digital learning. Okay, so law of cosines is this nightmare right here. Law of cosines is c squared is equal to a squared plus b squared minus 2ab cosine c. So that you know, I will never ask you to memorize this. I think you probably will know it eventually just because you use it so much, but it's not something that I would require you to memorize. You can see it's posted, if you can see, it's posted up. Can I do this? Up here. Yeah, law of cosines is there. Law of sines over there. But on a quiz or on a test, I'll leave it there. Okay, sorry. Let's move on. So we're going to prove why this thing works. We have our triangle, same triangle for law of sines. We have our ABC. We're still going to need to drop in an altitude because that's going to help us apply trigonometry to this. Okay. So drop in altitude. We're still going to call it H. Still going to be 90 degrees right here. Where do I have my markers? I have like 10 markers. No, I can't find them. This is still going to be 90 degrees. And then we're going to add in a variable x. X is just the distance from the altitude to C. And then we're also going to say, well, since that's x, the other side should be like b minus x, right? The whole thing's b, this is x, b minus x. Makes sense. Okay, so this theorem, the law of cosines, is called the Pythagorean theorem for non-right triangles. So let's apply some Pythagoras to this. And we're going to say, well, we have two right triangles. We have one right triangle over here. So we could just say quickly that a squared is equal to h squared plus x squared. I'm going to move this a little bit closer because we're going to really focus on our board. So I hope this is still visible. Okay, let's change that a little bit. Sorry about that. Maybe I'll edit that out, but probably not. Okay, here we go. Okay, so we have our figure here. Okay, a squared is equal to h squared plus x squared. Also on the other side here, I'm going to use this right triangle and say c squared is equal to this side squared plus this side squared. Still Pythagoras. C squared is equal to b minus x squared plus h squared. Okay, a little bit of algebra magic here. I'm going to expand this and I'm going to say c squared. Basically, I'm just taking these parentheses and expanding. So that's like b minus x, b minus x. And if you remember from your algebra teacher or pre-algebra, first, outer, inner, last, so b squared. So we get b squared minus bx plus x squared, b squared minus 2bx plus x squared. And that's exactly what we get here. We expand this and we get this thing right there. So it looks maybe scary, but it's just, just some basic algebra stuff. So we're going to simplify here a little bit. We see h squared plus x squared is here. H squared plus x squared is here. But we know h squared plus x squared is the same as a squared. So we take these two pieces, replace it with just a squared. Okay. So if we look at our goal, we have c squared, we have a squared, we have b squared, we have minus 2b. We have a lot of things we want in the final equation. The one thing we really don't like here is our x. X doesn't really fit into our law of cosines theorem. So let's see how we can get rid of that. We're going to say cosine of c is going to be equal to adjacent over hypotenuse. So cosine of c is x over a. I'm going to solve for x. So x over a, multiply both sides by a, multiply both sides by a, cancel, cancel. X is going to be equal to a times cosine of c, which is what we get there. Last step is that we just take our equation that we solved for before, and we replace the x with an a times cosine c. And really from there we're done, because we just need to rearrange this a little bit, put a squared out in front, right? Instead of a squared in the back, we put a squared out in front. A squared plus b squared minus, and then we're going to expand this a little bit, a squared plus b squared minus 2ab cosine c. Whew. So not too bad. We had to expand a little bit. We had to do a little replacement and then find our cosine value. But we get our equation for the law of cosines. So again, same way with law of sines. In order to get this to work, we had to draw in a right line, to form a right triangle. Going forward though, we don't need this line anymore. We can apply this theorem whether it's a right triangle or not. So from now on, and really from last class on, don't draw in any right lines. We can solve non-right triangles using our law.